Hello everyone. Now we are going to see the programmable logic controllers using logic gates. Here we need CPU module and then AC or DC power supply and then input and output modules. So in PLC, ladder diagram is the one of the major things. So here it's like a ladder. So here also we have a rungs and then branches also we have and then instruction like normally closed and normally open. This kind of instruction also, set of instruction also we have. So the basic instruction, loading instruction are normally open and normally closed and conduct in rising edge and falling edge. So there are around 5 important gates are there. They are, first of all, we'll see about the OR gate. So OR gate is nothing but of the addition process. So we know that 0 plus 0, 0, and then 0 plus 1, 1, and 1 plus 0, 1, and then 1 plus 1 is actually the higher value is 1, and then instead of that 0 to replace, I am going to off, and then instead of 1, I am going to replace on. Here I have shown the parallel connection. Here I have shown the parallel connection to implement the OR gate. So now we see the using virtual lab. So this one is here we can add the ranks. So this is open contact and then this one is output contact. This is normally closed contact. Now I am going to add a rank. So initially I am going to give the open contact. So as per our requirement, I need a parallel connection. So here we can add. So you have to click and then once again you have to click and then I am going to give the output. Okay. Now I have completed the diagram as per the diagram. So now I am going to compile our program. So what will be happen here? We have to give the labels. It means contacts. So we have to click the mouse and then we have to tag. So now I am going to give the switch 1 that I am going to give the switch 2 and then here I am going to tag as light or motor, whatever we need. So I have completed the ladder diagram. Now I am going to compile. So this diagram compiled successfully. Now we can run the program. So after running the program, you can see the green light from here and here. So I have used the normally closed. Hence here the input is 1. Here also the input is 1. So as per the our logic gates and the output also 1. So now we will check the gates. Now I am going to make both the inputs are as 0. So our output also 0. Now 0 and 1. So here 0, here 1, and the output will be the 1. So second one is also verified, and then 1 and 0. Here I am going to give 1. Here I am going to give 0. You can verify 1. Here 0, and then here 1. And then finally 1 and 1. So the final answer is also 1. So we have successfully verified the OR gate. We can verify it using this one also. Here the electrical circuit has been given. So now I am going to perform OR gate. So initially the battery is disconnected. Now I have connected the battery, and then the both switches are in off condition. See, the round indicates the in off condition, and then this side is off condition. Sorry, the left side is called off condition and the right side is called on condition. Now I am going to on. So you can see 0 and 1 will perform 1. 1 and 1 also perform 1. So the light is brightening here, and then now I am going to off both the switch. So then the output is also 0. So you can vary any switches. So whenever the 0 and 1 comes, the output also 1, which means we can on the light. Now I am going to perform AND gate. Now I am going to perform AND gate. So AND gate is nothing but of multiplication, basic multiplication. So 0 into 0, 0, 0 into 1, 0, 1 into 0, 0, 1 into 1, 1. So which means the both inputs will be the high. Both inputs will be the high, and then only we can get the output as high value. So we can create the series connection. So I am going to add a run. Here I have given the two switches, and then I am going to add light or motor, anything whatever we need, and I am going to give the contact label. Here I have given the name of switch 1. Here I am going to give the name of switch 2, and here I am going to give the tag as motor. I am going to compile. It is compiled successfully. Now I am going to run. So the both things are in green condition only. So now I am going to give the input. Here the input is 0. Here also the input is 0. So as per our truth table, if the both value is 1, switch 1 should be on, and then switch 2 also on. Only then we can get the power supply. If anything is off, like now I have done some switch off the 1, then the outcome is also 0, which means the motor will not run. Hence, the AND gates also performed successfully. So I am going to do in another manner using electric circuit also. Now I am going to connect the battery. Here I am giving the basic connection. So these are all the two inputs. These are all the two inputs. As per our truth table, both the switches are on, else the light will not on. Here the both the switches are in off condition. Now I am going to on switch 2. So there is no any happening here. And then now I am going to on switch 3. So now you can see the lights condition. The lights in on condition. So hence you can verify once more. And now the AND gate is also verified. Like that we can do for NOT gate also. So NOT gate is nothing but of whatever we are giving the inputs, it will give the opposite value, which means if I on the switch, the light will off. If I off the switch, the light will on. See, now the switch 2 is in off condition, but the light is in on condition. Now I am going to off the switch. Now I am going to on the switch, but the light is in off condition. And NOT gate also performed. Now I am going to do a little applications. Now I am going to perform AND gate and OR gate at a time. Now I am going to run a motor, two motors. Now I am going to run a two motors. My required condition is one motor should be run at a time, and then either one is in off condition. Only one motor should on. If the another one motor is on means, and then the earlier motor should be in off condition. So now I am going to make connections. So I need give the two inputs and two outputs. So I am going to give the two runs. Here I am going to give tag as switch 1. Here I am going to give tag as switch 2. Here I am going to give the tag as motor 1. Here I am giving the input as switch 1. The same power supply I am going to give here. Here also I am going to give switch 2. And then here I am going to tag as motor 2. Now I am going to compile. So the given ladder diagram is compiled successfully. So these two switches are normally closed. Now I am going to compile, and then now I am going to run the program. Here the given value is higher value. Here also the given value is higher value, and then the output is also high. Here the motor 2 is running condition. The motor 1 is in off condition. Now I am going to run motor 1, which means I have to off motor 2. So here I am going to off switch 1, which means now the motor 2 is still running, and then here I am going to off switch 2 also. So here I have after both the switch, now the motor 1 is running. So like that we can use whatever we need. Thank you.